Hello. Today we're going to be talking about adding probabilities. We add probabilities when our events are mutually exclusive or mutually inclusive. So we're going to start right away with an example. In the game Euchre, the deck consists of the cards 9, 10, Jack, Queen, King, and Ace in each of the four suits. What is the probability that? In number 1, the first card in a player's hand is a Jack or an Ace. So because of the word or, we know we're going to have to add. These events are mutually inclusive. That is, that they can happen at the same time. So the probability that we get a Jack, well, there are 4 Jacks out of, well, there's 1, 2, 3, 4, 5, 6. 6 times 4, because there's 1 for each suit, there's 24 cards in a Euchre deck. So 4 of the 24 are Jacks. Or means plus, an Ace, there are 4 of those out of the 24. So we add that together, we get 8 out of 24, and then we simplify, and that is 1/3. In number 2, the first 2 cards are both Jacks of the same color. Well, I have a couple different ways I can pull this off. If I want to draw a red Jack first, let's say. There are 2 red Jacks out of the 24 cards in the deck. And then I need to draw the other red Jack out of the 23. Or, so that means plus, or I draw one of the black Jacks, which is, there's 2 of those out of 24, times, and then I draw the other black Jack, which is 1 out of 23. And so let's simplify this up a little bit. The 2 and the 24 cancel and becomes 1/12. Same over here. 1/12. 1/12. And then we can multiply. So 1 times 1 is 1. 12 times 23 is 276. We can add that together, so 2 out of 276, and then we simplify once more, and that's 1 out of 138 when we take a 2 out of everything. So 1 out of every 138 times you're dealt 2 cards, you're going to get 2 Jacks of the same color. And then in number 3, the entire 5-card hand is all one suit. Well, if I'm going to choose, let's say, hearts, there are 6 hearts to choose from. The 9, 10, Jack, Queen, King, and Ace. And I only need 5 of them in my 5-card hand. So the number of combinations of those, we do 6 factorial over 6 minus 5 factorial times 5 factorial. Well, 6 factorial divided by 5 factorial is just the number 6. 6 minus 5 is 1, so we have 1 factorial, so it looks like we just get 6 over 1. There's 6 different combinations of 5 hearts. How many combinations are there of 24 cards? And I choose 5 of them. Well, that's 24 factorial over 24 minus 5 factorial times 5 factorial. And so this gives me 19. So 24 factorial divided by 19 factorial. 24 times 23 times 22 times 21 times 20 over 5 factorial is 5 times 4 times 3 times 2 times 1. And we start to cancel. 5 times 4 is 20, so that cancels with that 20. 3 times 2 is 6. 24 divided by 6 is 4. So when I multiply all this together, I get the number 42,504. So there are 6 ways that I can draw 5 hearts out of 42,504 different combinations of 5-card hands. But we also need to consider the fact that I draw maybe diamonds, and there's 6 combinations of 5 diamonds out of that. And there's 6 combinations of 5 clubs out of 42,504. And there's 6 combinations of spades out of 42,504. Or better yet, I can just do 6 times 4 out of the 42,504. And uniquely enough, 24 does divide out of this, the 42,504. So this actually simplifies into 1 out of 1,771. And so every 1,771 hands, you're going to get one hand where all 5 cards should be the same suit. And that's theoretically possible. We are done here.